we fairly divide seats in a legislature when different regions or parties receive different numbers of votes? Should larger groups always get more power, or should smaller ones have a fair share too? This is where Webster's method of apportionment comes into play. Developed by Daniel Webster in 1832, this method is used to fairly distribute seats among states, political parties, or groups based on their population or vote share. It is designed to balance representation, ensuring that no group is overrepresented or underrepresented. So, how does this work in real-world scenarios? Let's explore an example to see Webster's method in action.
So, the Webster method is a divisor-based apportionment system that allocates seats by dividing the total population by a commoner divisor and rounding the resulting quotas to the nearest whole number. Unlike Jefferson and Adams methods, which is round and biased manner, Webster method uses a standard rounding rules, which make it more balanced approach to representation. If the initial allocation does not match the total number of seats, the divisor is adjusted illiterally until the correct total is reached.
So before we go to the steps, let's understand some important terms. Number 1. Apportionment. It is the process of distributing a fixed number of seats among various states or regions based on their populations. This ensures that representation is proportional to the population size of each area. Number 2. Standard divisor. It is a value obtained by dividing the total population by the total number of seats available. So it represents the number of people each seat should ideally represent. Number 3. Quota. It is the exact number of seats a state or region is entitled to, calculated by dividing its population by the standard divisor. For short, quotas are often fractional numbers. Number 4. Rounding method. In Webster's method, quotas are rounded to the nearest whole number. This differs from other methods, such as Jefferson's, which always round down, or Adams, which always round up. Lastly, modified divisor. It is an adjusted divisor used to ensure that the total number of seats after rounding matches the number of seats available. If the initial rounding doesn't allocate all seats, the divisor is modified and quotas are recalculated. For short, this is a new divisor that we adjust to make sure that the total numbers of seats matches the given amount.
When solving or using the Webster's method, first we have to determine how many people each representative should be represented. We have to do this by dividing the total population of all the states by the total number of representatives. The answer of this is what we call our standard divisor. For step 2, we have to divide each state's population by the divisor to determine how many representatives it should have. We have to record this answer to several decimal places. This answer is what we call our quota. For step 3, we have to round all the quotas to the nearest whole numbers. But don't forget, we have to know what are the decimals, or what were the decimals. Add up the remaining whole numbers. The last step, if the total number from step 3 is less than the total number of representatives, then we reduce the divisor and recalculate the quota and its allocation. If the total number from step 3 was larger than the total number of representatives, we increase the divisor and again recalculate the quota and its allocation. We continue doing this until the total in step 3 is equal to the number of representatives. The divisor that we end up using is called the modified divisor or our adjusted divisor.
Now let's try a sample problem. Imagine a country with 4 states, A, B, C, and D. The total population is 1 million, and we need to divide 100 seats among these states. The populations are: State A, we have 180,000. State B, we have 260,000. State C, we have 310,000. And lastly, State D, we have 250,000.
Let's solve for this problem using Webster's method. So need to find our standard divisor. To get our standard divisor, we need the total number of population divided by the total number of seats. In our case, our total number of population is 1 million and total number of seats is 100. So mo siya like 1 million divided by 100 is equals to 10,000. So ang kanan 10,000, that's our standard divisor. So next, what we're going to do is we need to find each state's quotient or like the quota. So let's say state A has 180,000 na population and you divide it by 10,000 na SD na to. So may equal siya og 18.0. Ang state B, kaya siya 260,000 na population divided by 10,000 na SD is equals to 26.0. Ang state C, kaya siya 310,000 yeah, imo siya divide og 10,000 na SD, so may equals siya 31.0. And lastly, our state D, kaya siya 250,000, kaya imo siya divide og 10,000, so may equals siya og 25.0. So next step is we're going to round it off. So we need to apply Webster's rounding rule. The Webster's rounding rule can normally mo round off that to the nearest whole number. So remember, itong state A ganiha kay 18.0. So of course, the whole number na duulan na kay 18. So state A is 18, state B is 26, state 3 is 31, and state 4 is 25. So after that, and round off naman nato, we need to verify the total seats. Remember, our total seats earlier is like 100. So we need to add everything. So 18 plus 26 plus 31 plus 25 is equals to 100. So meaning, kay 100 man siya exactly. So atong apportionment kay correct. Mo na siya. So mo to siya. Ang state A kay 18 seats, ang state B kay 26 seats, ang state C kay 31 seats, ang state D kay 25 seats. So equals to 100 seats. So sakto siya. That's how you get that.
Interpretation, the apportionment using Webster's method successfully and fairly allocated 100 seats among the 4 states, ensuring each state's representation is proportional to its population. The results demonstrate the effectiveness of Webster's method in achieving accurate and equitable distribution.
So overall, Webster method is about fairness, accuracy, and balance. It reminds us that representation should reflect the people's voice as accurately as possible. Understanding methods like this help us appreciate the importance of fair elections and decision making.
Here are the references used in this topic.
Now that you know how Webster method works, what do you think? Should more countries and organizations adopt to it? Thank you for listening. Bye-bye!